Have you ever wondered how two different things relate to each other? How can we measure the relationship between two variables? Today, we unravel the world of statistics to answer these questions, diving into a concept known as covariance. Covariance is a statistical metric that reveals the extent to which two random variables change in tandem. Imagine two dancers moving in sync on a dance floor, or two swimmers keeping pace in a pool. When one moves, so does the other. This is the essence of covariance. It tells us if two variables have a positive relationship, meaning they move in the same direction, or a negative relationship, indicating they move in opposite directions. Now, how do we calculate covariance? It's the average of the products of the deviations of the two variables from their respective means. In simpler terms, it's how much two variables vary from their average values at the same time. The mathematical representation of covariance looks like this. Cov x, y equals the sum of the products of the deviations of x and y from their mean values, all divided by the sample size. Here, x and y are the two random variables, and the Greek letter mu represents their means. But what do the values of covariance tell us? Well, the value can be anything from negative infinity to positive infinity, with zero in the middle. A positive covariance means a positive relationship, indicating that the variables move together. A negative covariance, on the other hand, means a negative relationship, suggesting the variables move in opposite directions. And a zero, that means there's no detectable relationship between the variables. Covariance isn't just a mathematical curiosity. It has practical applications in diverse fields. In finance, it helps assess the correlation between price movements of different assets. This insight can guide investment strategies, helping investors diversify their portfolios and reduce risk. In social sciences, it can evaluate the strength of associations between factors like income and education. In neuroscience, it can measure the strength of neural connections between brain regions. And in engineering, it can assess the reliability of systems with multiple components. So, to sum up, covariance is a powerful statistical tool. It quantifies the relationship between two variables, providing insights into how they behave together. Whether it's portfolio diversification, understanding social phenomena, exploring the brain, or designing reliable systems, covariance offers valuable insights for informed decision-making. So, the next time you see two things moving in sync, remember, there's probably a covariance working behind the scenes.